Magic Hour. Welcome everyone, and I'm going to invite this afternoon's webinar moderator, Andrea Dickinson from Tri-County Literacy Network, to introduce this afternoon's webinar. Andrea, go ahead, please.
Thank you very much, Sarah. Good afternoon, everyone. And I'm a member of the Online Community of Practice Working Committee, and I will be your moderator for today's webinar, Making Math Fun. I'm very pleased to see that today's topic has caught the attention of so many people from across Ontario. To begin, I'd like to say a few words about the LBS Online Community of Practice. It's a series of webinars that has been developed collectively by members of Ontario's LBS regional networks, sectors, and the provincial support organizations for literacy. Our goal is to provide affordable, because it's free, professional development to LBS practitioners on topics that are important to them. We have been providing these webinars since 2015-2016, 5 per year, and you can find all the previous webinar presentations, recording links, and transcripts at the link you see on the screen. We are always interested in hearing about topics that are timely and relevant to you, so if you have any webinar topic ideas, please send them to us. Today we're going to start our webinar with a little Canadian humor on measurement. Thank you to Deb Flynn of the Quill Learning Network for this contribution. And it's Rex Murphy on the point of view. And I'll turn it over to Sarah to run that for us. Thank you, Sarah.
A new poll from Angus Reid doesn't look at how Canadians measure up. It looks at how Canadians measure. Canadians went metric in the 70s. But here we are, a full Trudeau later, and we're still having trouble losing the last few pounds, as it were. When it comes to temperature, Canadians prefer Celsius to Fahrenheit. But when we weigh something, we carry the weight in pounds, not ounces. When we cook, Canadians follow recipes in Fahrenheit, yet we drink litres, not gallons, and quarts, unless it's a beer. Then it's a pint. Ask a Canadian how tall he is, he'll tell you in feet, not metres. But ask him how much he weighs, he'll answer in pounds, not kilograms. Ask him how much land he owns, he'll tell you in acres, not hectares. But ask him how far away it is, and he will tell you in kilometres, not miles. We are the only country with 2 official languages and 2 units of measurement. And why? Because to be Canadian means to be eternally sitting on a fence. A fence that's 12 metres long and 6 feet tall, apparently. To be Canadian means to be only 2 things, not a Brit and not an American. So we are stuck somewhere in between until our idiot neighbour to the south does what the rest of the world has done and go metric, which will never happen. Because if a Canadian tries to explain to an American that 1 millilitre of water occupies 1 cubic centimetre, weighs 1 gram, requires 1 calorie of energy to heat up by 1 degree centigrade, which is 1% of the difference between its freezing point and its boiling point, the American will pause, contemplate, and then respond with, "Trump rules!" For the National, I'm Rex Murphy.
Thank you very much, Sarah, for playing that for us. Just a little bit of humor to start things off. In today's webinar, we will be learning more about making math fun. In this webinar, we'll be looking at 3 key areas: general principles and approaches to making math fun. We'll also be finding the wonder in math. We'll move on then to look at gamification of math. After the 3 mini presentations, we'll look at making math fun using videos, blogs, and cartoons resources. And then we'll have some time for a question and answer period. The presenters have asked that questions be held to the end of their presentations when we get to the question and answer period. So we really appreciate you're just holding off till then. And I mentioned we have 3 main topics, and we're also fortunate to have 3 excellent presenters who are with us today to share their knowledge and experience. I'd like to take a moment to introduce our panelists. We have Barb Glass, Executive Director of the College Sector Committee for Adult Upgrading and a longtime math instructor, to talk to us about general principles and approaches to making math fun. We have Wayne Medema, instructor, Essential Skills Upgrading, Waterloo Region District School Board, to talk about finding the wonder in math. Wayne has kindly stepped in to replace Steve Ballard, who has moved to another job. Last but certainly not least, we'll hear from Summer Burton, Project Manager, Literacy Link South Central's gamification project, to talk about gamer psychology and the gamification of math. So first off, it's my pleasure now to turn things over to Barb Glass.
Thank you, everybody, and thank you, Andrea, for the introduction, and Sarah for getting us all set up today. I'm really happy to be here and have a chance to chat about, a fun topic. And some of you in your history with math might not think it's fun, and certainly lots of our learners don't think it's fun, but I think that was a great way to start off with the video that we just saw. I realize a couple of people weren't able to access it, but if you weren't able to, Sarah will send you the link, and I think you'll get a little bit of a laugh out of it. And really, it does set the stage today for the at least this first part of the discussion in making math fun, and certainly for the contributions of our other presenters as well. There are, I think, some themes today that just underscore good teaching practice. And in this first section, that's the case, but we're just making it a little more contextualized toward math. I'm just going to start with an excerpt from an article that I found recently. It's called How I Finally Got Over My Fear of Math. And there's just a couple of paragraphs on this slide and then one on the next slide too. I'll read it with you. The classroom smelled like feet. It had no windows and was lit by those awful overhead fluorescents that make everyone over 25 look like an extra from The Walking Dead. Not that this mattered to most of my classmates, who looked barely 18 and were probably wondering what the old lady was doing in their community college pre-algebra class. But none of this was as uncomfortable as what was facing me on the whiteboard. A long, complicated mess of an equation, full of parentheses, exponents, and negative signs. Somehow, I had to come up with the answer. I bent over my graph paper and started to calculate. All too soon, the professor called time and began walking around checking our results. I was in the second row, so he got to me quickly. I pointed to my solution. That's correct. None of my friends and family understood why I'd suddenly decided at age 38 to revisit high school math. Why would you do that to yourself? My friend Nina, an attorney, asked over lunch, her eyes wide as she sipped her pomegranate iced tea. Because I got sick of believing I suck at math. So I think there's lots of adults out there who could relate to this. And, it doesn't matter what kind of an upgrading program you're in, whether it's a college program or a school board or community-based or online, very few people think of math as really being fun. And we had the last webinar was on math anxiety. So this is really a nice little continuation of trying to help people over their math anxiety by making it a little more fun. So when I was thinking about what I could share with you today, this is the little list that I came up with. And again, not all of it applies only to math, but we'll put it in the context of math today. Use humor. We've already started by talking about that, and you'll see the slides that I'm using and that others are using throughout the presentation are full of little math cartoons and jokes and things like that that really can help people to be engaged in math. Of course, our own attitudes about being positive toward math is important, seeking input from learners, providing positive reinforcement, incorporating technology, and just in case you missed it the first time, using some humor. One reason that I really enjoy using humor in teaching math is because it just brings it down a notch for people. It just makes them I find with adults especially, just a little more willing to maybe be open to the fact that even though math can be a little bit scary, it's really, really not that bad. So that's why I have stated here, it really helps sometimes to take the mystery and intimidation out of math. And again, that could be true of other subject areas too, but especially math because there's just so much math phobia out there. And because for years it's been okay to be bad at math, even though we would very rarely hear somebody saying, oh yeah, I'm really bad at reading and writing. Because it's just not acceptable to be bad or to admit you're bad at reading and writing the way it's acceptable to say, oh yeah, I was never any good at math. Here's another little one that struck me as funny, even though it's from a children's class. Sam can make 11 beaded necklaces in an hour. Sue can make 12 beaded necklaces in an hour. In 1 week, Sam made necklaces for 6 hours and Sue made them for 3 hours. Who made more bracelets? So the astute child said nobody was making bracelets because they were actually making necklaces. Just a couple of other quick examples. And these things I just pulled off of a search on Google that said free math humor or free math animations humor. And so my point here in showing you a few of these is just that it's not hard to find them. And it was really quite entertaining to go through and see how many really funny, quick little things there are. I once worked with a teacher who on every assignment she handed out to her class, this was in a college, she found some little cartoon to put on the cover page of the assignment, because I think she also understood that just that little bit of humor sometimes takes the edge out of the trepidation that lots of students feel. Next, I would just talk a little bit about our own attitudes as teachers and practitioners toward math. And even if you have some trepidation and fear about math, it's really important to try to avoid, communicating that to your students. And I would venture to say that lots of adult students who come into our math programs and our math classes, whether it's in LBS or other adult ed programs, they reflect back and they think about all the pen and paper and pencil and paper calculations they did and how arduous a lot of that was. But really, one of the things we can do is just help them understand that it's not all about pencil and paper calculations. And we'll talk a little bit more about using some hands-on materials a little bit later in the presentation. We can also talk about the fun and humor in math, as we've been discussing. And as you'll see in Wayne's presentation, there's a lot of beauty in math that people don't even recognize. I think it's important also that we cultivate an atmosphere in the class where students can share the things that they achieve. However you as a teacher or a practitioner decide to celebrate successes, it's important. And maybe more important in math than other subjects, again, because of the anxiety that so many people come with. And then the fourth bullet is one that I think is sometimes less obvious. When we get into work in maths and sciences, we find often that it's almost like another language. There's so many terms, terminology, and the use of words in math and sciences that's different than the way we're using them in everyday life, or they just don't even exist. So things, like sum, quotient, dividend, product, even those simple terms that if we're familiar with math, we might think are not too daunting, they can really be daunting to people. And in particular, lower level students who may not have really strong reading and writing skills to start with. So if we can help to, and I use the word demystify those terms, whether it's through some, some kind of a game, or just through a discussion, or through having a list on the wall. And when a student comes up with a term in math that they don't understand, it goes up on the wall, we talk about it, we just make a quick little note of what it means. So there's lots of different ways to take the intimidation out of it, especially when it comes to the language of math. Some of you will quite no doubt be familiar with lots of math fun facts that are out there. And here's just a couple of examples. And again, looking ahead to Wayne's presentation, he's got a few more that he can share with us as well. The first one talking just about how if you cube certain numbers, each of their digits, they will actually add up to the sum of their cubes. Now, obviously, that's a topic that's a little more advanced, but even the next one in the red bubble, if you take your age, multiply it by 7, then multiply by 144, the product repeats your age 3 times. It doesn't necessarily important that people understand why it happens. It's just a fun way to illustrate that there are some cool things that happen with numbers. It's not just all about long, boring, drawn-out calculations. Equally important, I think, is to talk sometimes with your students about why math isn't fun. give them an opportunity to explore some of the reasons why they didn't like math, that it's okay to have come in with some fear about math or some dislike of it, and that, you know, you're committed to working with them and hoping that you can make it a little more fun and a little more enjoyable. In my work, which has mostly been in college upgrading programs, but also in a couple of other areas of teaching math to adults, is that often, once they get over that fear, they tend to often grasp things more easily than they did when they were in school the first time. Could have, you know, there could be many reasons for that. Maybe it's because in some form they're choosing to be with us at this time rather than being forced to be at school, perhaps when they were younger. Maybe it's just because our brains are better developed and more developed and we have more connections that allow us to learn math more easily. But I have lots and lots of recollections of students saying to me, wow, this is so much easier than when I tried to do it in grade 5 or grade 7 or grade 9 or whatever it was. So bottom line there, you know, misery loves company, and if someone comes in and really, really doesn't like math, there's chances are there's someone else in your class that has experienced it, and maybe they can even provide some uplifting words for those folks that come in and are still really reticent about math. So that leads into my my next area approach or principle that I believe is important and that's fairly easy to do. And again, it does relate to other subjects. If we can get some input on learners, especially about input from learners, especially about how they like to learn, then if it's a subject like math that might cause them some stress, then if we can try to provide ways for them to learn that are best suited to them. And I don't just mean so much learning styles, although of course that's important, but I just really mean, you know, if they're learning math, would they rather just be all by themselves in a study carrel or a private place, or do they like to be with other people so they can bounce ideas off of them? Do they like doing hands-on work or not? So, you know, if they're more kinesthetic learners, then they might like to do some work with manipulatives or hands-on materials. Others might not. So if we already know the subject's causing them stress, if we can help them learn in a way that will be favorable to them and will provide some level of comfort, then let's try to do that. Some love peer learning, some love working with other people, some don't. And some learners, as you know, really take on the mentoring role quite well and can provide some extra support and help to the ones that are struggling. And again, not just specific to math. So actually, I just alluded to this a moment ago. Maybe you can pair up a learner who's been in your program for a little while with a new learner that can provide a little bit of advice, a little bit of positive reinforcement, and a little bit of just, hey, it's okay, math really isn't that bad, and I struggled when I came in, and I didn't like it when I was in school, but, you know, now it's okay. And I'm not even being entirely facetious in saying there must be a milestone to give credit for learners in the engage with others competency or elsewhere, if you even want to promote the mentoring to that level. Thanks, Sarah. Yeah, it is kind of I actually chuckled to myself when I wrote that in there because I know we're all concerned with that. Also, the activities and our learner plans and what we're putting in them. And so any way we can give credit for something that students are helping to do, so much the better. I just want to talk for a few minutes about using real life materials. There's lots of them out there for math, and I'm sure you're aware of many. One area that lots of people struggle with is fractions, and you may or may not be familiar with the concept of fraction bars. This is just a picture of what fraction bars look like. So as a teacher, you would cut all these up and use them on a comparison basis to help students relate to, you know, in this case, 8/6, 4/4, 1/3, halves, and wholes, but you can do it for, you know, other combinations as well. You can actually buy these often at teacher stores. They wouldn't be that hard to make. So that's just one idea of what we tend to call a manipulative, something that students can actually use in their hands to, as I'm saying here, to touch, to count, to arrange, to sort, to combine. So that is just one example. And I don't necessarily think that it's only applicable to use these for, for youngsters, for kids. Kids get to do this all the time in primary school, we hope. But just because we work with adults, it doesn't mean that they don't also benefit from actually hands-on learning and working with real objects, especially when it comes to math. So other materials that you might be able to incorporate into some demonstrations or lessons or group work, obviously measuring tools, scales, store ads, Monopoly money or whatever kind of fake money you might want to pick up at the dollar store, and even something that is a form or a document that they use that can be involved with some calculations, like a pay stub or a check stub or any kind of document like that you can use to help make the math a little more real. Now I say that with the caveat that I've written here. Probably it takes a little more time to construct lessons or activities using hands-on materials than it does just using pen and paper, but honestly, the reward and the applicability to our students is great. You might be able to collaborate with other teachers. You might be able to find some of these, things from colleagues. But even doing one or two kinds of activities like this with hands-on materials, and it certainly applies more at the lower levels. It does get harder, admittedly, to do hands-on activities when you get into slightly higher level math. But my other observation is that often by the time learners get to higher level math, then they have largely gotten over a lot of their anxiety, and if they've had a good foundation in basic math, then they can, more readily, I'm going to use the word loosely, kind of buy into the higher level math that they might need to do to achieve their goal. That's just my observation over the years. I would say in my almost 30 years of teaching math, this is the single most useful strategy that I have ever employed. And I taught a lot of one-on-one math, and adult learners were just so devoid of any positivity around math. So even if they had a solution that had 3 or 4 steps and they got the answer wrong, if they got the first step right, I was always careful to say, hey, you got the first step right. Let's look at what the rest of it, how we can correct the rest of it. Because so much of the challenge that people have and the reason they don't feel like math is at all fun is because they have no confidence in themselves. So I really encourage you as adult educators, again, in any subject, but especially in math, to really use that strategy of positive reinforcement verbally, in writing, individually with the group, however it seems to work in your learning environment. It also makes students a little more willing to come and ask for help if they realize that, you recognize when they do something right, even though they may not always get the answer right as far as, a full math problem or something like that. And this is my little bit of philosophy for the day from Einstein. So it's not mine. I just happen to like it. Everybody's a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing that it is stupid. And there are other paraphrases of this, but I think, again, in math where people feel especially reticent and not confident, it's important to also stress to them that maybe if they do struggle with math, that's okay. They're good at other things as well. And then finally, and just as a little bit of a preview also to Summer's session and her presentation, there's a lot of technology out there that we can use in math, and a lot of it is free. And Summer's going to talk a little bit about gamification, but I would just draw your attention, for example, even to the many, many, many lessons that are on YouTube. There are free study sites, for example, the Khan Academy, which I believe that Wayne also referenced, or that I think we referenced at the end, although I believe I might have spelled it wrong there. I think it's Khan. And then another thing that you may have heard of is something called Kahoot, another name brand is Quizlet. And those are little interactive pieces of software that students can use on their phone. So for example, you could have a question up on the whiteboard or a question on a piece of paper, however you're doing it. And then the software allows students to answer the question, whether say it's a multiple choice or a true false, just something where it's a quick answer. And then the whole group can see not individual answers, but can see people's different, you know, how many people thought it was A, how many people thought it was B. So it's just another quick little interactive teaching tool. However, it does require learners to have a device. Most of them have phones, but I recognize that they don't all have them. Sarah, can we just take a quick look at that video? I think that we loaded it.
We did, Barb, and I will click on the video. I do want to reinforce the fact that we are going to be circulating this presentation, so if anyone is unable to watch a video, please know that you'll have the links in your presentation. And I did notice that there were 3 of you, I think, who said you lost your audio after the last video or perhaps during it. If that should happen, it may be some sort of combination of softwares in your browser and your system. Do know that logging out and logging back in again should restore it. This is a very brief video, so let's just try it. And let me move to the right video now. And I'm just going to ask you to bear with me. I'm going to try to fast forward past the ad. Hang on, everyone.
In a previous video, we learned all about factoring whole numbers. And now we're going to learn how factoring can help us when working with fractions. We're going to learn how to simplify fractions. Simplifying a fraction means rewriting the fraction using the smallest top and bottom numbers we can without changing the value of the fraction. To help us understand what simplifying a fraction really means, let's take a look at the simplest fraction I can think of, 1/2. Now, this is already as simple as it can possibly be, so let's go the other way and complicate it by dividing our rectangle here up into more parts. The amount of our rectangle that's shaded is still the same, but now the numbers for our fraction are 3/6. The numbers are bigger because our rectangle is now divided into more parts. The fraction we have now, 3/6, is equivalent to our original fraction, 1/2. That means they have the same value. They represent the same amount. So what if someone gives you the fraction 3/6, like 3/6 of a candy bar? Well, we know from our picture
Sarah,
that means they're really giving you 1/2.
Great, thank you. Just get back to the slide here.
I put it back, Barb.
Oh, thank you. Okay, perfect. Thanks for doing that, Sarah, for showing us that quick video. My point with showing you that is just, if you're not aware, just to illustrate that there are some great math lessons on YouTube that are free. As you could see, that instructor, I think, would have been very appealing to our adult students. And he was able to incorporate the visuals, which were really the fraction bars I alluded to before, in a really nice little high-tech way within that video. So anyway, if you're not aware, you are now, that you can access some pretty nice things on YouTube. The other nice thing about it is students can view those outside of your class too. It doesn't mean they just have to look at that kind of a resource when they're in class with you. Yes, just in case you missed it again, the first 7 times I said it, the more you can use humor, the better. I hate the idea that when it comes to books and learning, hard is often seen as the opposite of fun. It's strange to me that we should be so quick to give up on a book or a math problem when we are so willing to grapple, for centuries if necessary, with a single level of Angry Birds. That might particularly resonate with some of our younger learners who play Angry Birds. I don't play Angry Birds, but I did know what it was, so it resonated with me a little bit too. And then finally, just before I pass things over to Wayne, one last little cartoon, which is also one of my favorites as well. I've enjoyed having the chance to chat a little bit today. I look forward to some follow-up questions at the end if you have any, and just really encourage you to again try and demystify math, try and take the language of math and work through it with your learners as you need to, and be positive about it, get feedback from them to help them learn in the best possible way they can, and throw in some funny stuff whenever you have the opportunity. So with that, I will conversion.
Thank you very much, Barb. I just had one quick question here from Maria. Where did the video come from that you played?
It's from YouTube.
Okay.
So
they
if
can
you
just look it up by
yeah,
the
so
name.
you can Google, for example, if you Googled just that topic, simplifying fractions, then you would get a number of them. And there's a whole series of that one called Math Antics.
Great. Thank you very much, Barb. And it's my pleasure now to invite Wayne to provide his presentation after the excellent presentation from Barb. Thank you very much, Barb, and welcome to Wayne.
Thank you. Good afternoon, everyone. Barb talked about taking the mystery out of math, and I'm going to talk about putting the wonder into the math. And when I talk about putting wonder in, I'm talking about putting a wow onto the math. You might be wondering what the seahorses and snails have to do with math, but I'm going to keep you in suspense until we get to slide number 6. When I ask my learners where things went bad for them with math, they can sometimes point to negative experience that they had with math, or negative attitudes about math that kind of fueled their decision to dislike it. So I believe that 2 things that I can do in the classroom to counter these negatives are to be intentional about expressing my positive attitude towards math, and that's something that Barb already mentioned. And the second thing, to nurture a sense of curiosity and wonder for numbers and math, and I think that's really something that sometimes draws people in. So I want to start with apologies to anybody who was in my grade 4 class at Alliston Union Public School. I'll start by telling you about 2 significant events in my math life. The first significant event was in 1976 when I was in grade 4. So my best friend at the time was Stuart. Stuart lived down the street, and he was the first guy in the neighborhood who had an Atari video game console. And he also liked math. I remember that in that grade 4 year, I made the conscious decision that I was going to like math too. Now that hasn't meant that math has always been easy for me though. I got 16% on a university stats exam, but liking math, I think for me, has meant that I've been able to sustain interest long enough to figure something out. So when I reflect on this grade 4 experience, there's a couple of things I think I pull out of it for myself. One is that liking or disliking math is probably a conscious or maybe an unconscious decision that we make. And if that's the case, it's a decision we can revisit and change our minds if we want to. The second point is that liking math doesn't mean it becomes easy. The third point is that I can choose to like math even if I don't find it easy. And the last point, that liking math is something that can help me to sustain my interest long enough to be able to understand a difficult concept. So my goal when I'm working with math learners in the classroom is not necessarily to try and make math easy. Some of our learners just find things hard to learn. But if I can nurture a sense of curiosity and wonder, then the person can sustain their interest long enough to figure things out. The second significant event was in 2009 when my family and I went to Malawi. I taught the equivalent of grade 11 and grade 12 math in a high school. The school was at the base of a mountain that people would climb for the challenge and for the amazing views that would make their heart flutter. Now there was a moment in that math class that I got that same fluttery heart feeling after working out long division of a polynomial. So I stood back at the board and the process just looked so elegant. And I turned to the class and I paused and I said with a smile on my face, "Wow, that is beautiful." Now, over the course of the next few months, I continued to verbally and non-verbally express my delight about the math that we were doing, and this attitude was caught by the students in the class to the point where at the end of the term, we would work out a problem on the board, and all I would have to do would be to turn to the class with a smile on my face, and all 70 of them would say in unison, "Wow." So I think by expressing my attitude of wow and wonder that they caught a bit of that for themselves. Now, when I asked my current class of numeracy learners what made math fun in our classroom, they mentioned some of the things that Barb has already mentioned. But they also mentioned attitude. And they said that math is more fun when it's taught with enthusiasm, because enthusiasm is contagious. So makes me think that that pause, that smile, that wow, that is catching. And it can provide an antidote to the negative attitudes and experiences, and it can clear a space for interest and wonder. Now, the first presentation on why math, Jane Tour pointed out that children often take on their parents' attitudes towards math. When a parent says to a child, "I hate math," the negativity is contagious, and the child is more likely to dislike and therefore struggle with math. So if we in our programs can help people to decide to change their feelings about math from hate to interest, or for dislike to interest, this too is going to be contagious for their children, and it sets their children up for more success in their future math classes. So these two experiences that I've mentioned, grade 4 and 2009, have taught me these two things that I try to bring to our math classroom. The first, to be intentional about expressing my own sense of curiosity and wonder about math. And the second, to try and nurture in my learners a sense of curiosity and wonder. So the next few slides in this presentation are going to be about some examples of things that I think can nurture a sense of curiosity and wonder about numbers in math. And they fall into three categories, really. The first, we'll start talking about some human stories behind math, because math to some degree is a human story of discovering patterns and relationships. The second one is looking at some of those patterns and relationships. And the third category that we can talk about to increase a sense of wonder and curiosity is connecting math to our worldview. So to start off, let's talk about Fibonacci, a human story behind math. So Leonardo Fibonacci was born in 1175 in the town of Pisa, the same town where 200 years later they built a tower that to this day has a terrible lead in it. His father was a customs official who moved the family to North Africa when his job posted him there. North Africa at that time was the part of the Arab Empire, and Fibonacci took the opportunity to study under some Arabic mathematicians. Now back home in Italy, Roman numerals were the numbers that were used in business and education, but the Arab mathematicians taught him a new system of numbers, which they had probably learned from Hindu mathematicians. And that new system of numbers is the root of the Arabic number system that we use today. Fibonacci discovered that the Arabic numbers with their place values were far easier to use than the system of Roman numerals. So in 1202, he wrote a book about what he had learned and introduced Europe to Arabic numerals, which eventually replaced Roman numerals, except for the credits in movies, I believe. He's probably better known, though, for a puzzle he posed about rabbits. So the puzzle goes like this. A certain man put a pair of rabbits in a place surrounded on all sides by a wall. How many pairs of rabbits can be produced from that pair in a year if it's supposed that every month each pair of rabbits begets a new pair, and every new pair from the second month on becomes productive? So if you look at the slide on the right-hand side, the bunny pairs, so on the first month, 1, second month, 1, now they become productive, now there's 2, and so on. It creates a really interesting sequence of numbers that's at the bottom of the slide. The answer is the Fibonacci number sequence, 1, 1, 2, 3, 5, 8, 13, and so on. What's interesting about the sequence, one thing, is that pick any number in that sequence, and it's the sum of the two previous numbers in the sequence. Now, over the years, the numbers of that Fibonacci sequence, the numbers that I mentioned, like the 1, 1, 2, 3, 5, 8, and so on, have been discovered in all sorts of patterns in nature. The number 3 and 8, they're both in the Fibonacci sequence, and they're found in the arrangements of petals in flowers, such as lilies and irises. On average, flower petals do coincide with the Fibonacci numbers. This curious resemblance extends to a wide range of plants and objects in the natural world, from the arrangement of scales on a pine cone to the seeds in a sunflower. If you use the Fibonacci sequence to build a Fibonacci spiral, and this is what's on the screen in front of us, there are the numbers again, 1, 1, 2, 3, 5, 8, and so on, it ends up creating a spiral that's the same spiral that we can see in the nautilus shell that's also on the screen to the right. And now we're back to the seahorse and the snail. So that Fibonacci spiral generated by the Fibonacci sequence is found in the spiral of a snail shell, the spiral of the petals of that rose, the spiral in the ends of the leaves of that plant, the spiral of the cloud pattern in the hurricane, in the tail of the seahorse, and in the spiral of that nautilus shell on the right again. So that's, I think that's just a big wow. Interesting how Fibonacci discovered this sequence of numbers that show up in so many places. This is the second human story. I don't know if René Descartes was fond of sunglasses, but the picture says he was. René Descartes. So this story is probably more legend than fact, but it gives a humorous way to introduce graphing. So graph paper is an example of a coordinate plane. It's a two-dimensional flat surface where every point can be given an address with an ordered pair, such as on the graph there, 4, 6. The coordinate plane is also known as a Cartesian plane, and it's a nod to René Descartes with his last name. It's taken as fact that René Descartes suffered from fragile health. He needed a lot of rest and spent a lot of time in bed, and it's probably out of that that this legend comes now. Legend says that while he was resting in his bed, he watched a fly walk around on his tiled ceiling. You can see it in the picture, Buzz Buzz. His mind began to wonder if there was a way that he could name the location of the fly at any moment in time. And he noticed that the grid lines in the tiled ceiling gave him a way to measure the distance away from the starting point, which was one corner of the room. So think of that as 0, 0. He used the grid lines running in one direction to measure how far the fly was to the right of the starting point, and in the picture it's 4 to the right. He used the grid lines running in the other direction to measure how far up the fly was, and that's 6 in the diagram. And he now had a pair of numbers and decided to put the pair together always in the same order, right, left first, and up, down second, separated by a comma, held together by brackets, and called it an ordered pair. So we use Descartes' Cartesian plane to this day. Now, there are so many other interesting human stories about math that are just a Google search away. We saw the Go Metric video at the beginning of the presentation. A fascinating story is the development of the metric system during the time of the French Revolution. It was out of a system where lots of people in places had different systems of measurement, and there was a push for a common system of measurement. During the French Revolution, they tried to decimalize everything, making everything to have a base number of 10, which the metric system does have. They even went to the point, though, of having a 10-hour clock and a 10-day week. Those things fell apart. They didn't last very long. But Googling the story of the metric system is a fascinating story, books written about it, that can generate a whole new perspective on this thing that we consider sometimes a thorn in our side. It was certainly a thorn in the side of the people who took 7 years to survey the distance across Europe. Another story you might be familiar with is the story of the Gimli glider, an Air Canada Boeing 767 that ran out of fuel over Gimli, Manitoba, because someone calculated the amount of fuel in pounds instead of in kilograms. So the story of the Gimli glider, a really important story to make the point about careful calculations. So on now to discovering patterns and relationships in math. So this is one about the 9 times table. Maybe I can get people to click on the hands up thing if they're familiar with multiplying on your fingers like we're seeing here. So lots and lots. I'm going to scroll. Oh, almost everybody. Okay, so I'm going to start on the left-hand side of the screen. So Patterns within the 9 times table. I know for myself, the 9 was probably the one that I memorized last, but the patterns in it are stunning. So on the left side is a part of the 9 times table. Answers are written with 10's digit in blue, 1's digit in green, and a pattern that pops right off the page is that the 1's digits are decreasing as you go down the page. The 10's digits are increasing as you go down the page. That's a pattern that's pretty obvious. Another pattern that's less obvious, but it's also there, is if you pick any answer and add the blue 10's digit with the green 1's digit, you will always get 9. So pick 27, 2 plus 7 is 9. Pick 36, 3 plus 6 is 9. So I talk to our learners how a quick test, if you've got the right answer for a 9 times table answer, is to add the 10's and the 1's digit, and if it adds to 9, you know you've got something coming from the 9 times table. I was curious to see if the pattern pushed farther than 9 times 10, so I randomly picked 243 times 9. 243 times 9 is 2,187. If I add the 2 and the 1 and the 8 and the 7, I get 18. If I add the 1 and the 8 of the 18, I arrive at 9 again. And that's pretty neat. So that's one pattern in the 9 times table. When I was looking at how many people were familiar with multiplying with fingers, I saw there were some that didn't raise their hands. So I'll just explain it quickly. On the right-hand side, if you hold your hands out, so they're palms up, and imagine like on the slide that every finger is numbered from 1 to 10. And again, this only works for the 9 times table. If you take a finger, let's choose an easy one, finger 7, put down finger 7, and look at how many fingers are to the left of finger 7. And I've got 6. Look at the number of fingers to the right of finger 7, and I've got 3. So to the left of finger 7 is your 10's digit, 60. To the right of the finger 7 that went down is the 1's digit, so the answer is 63. So a really neat pattern. These two things that are on the slide right now are often things that I will show to people. We've got a continuous intake in our program, but when someone comes in and confesses, or it becomes clear that their comfort level with math isn't very high, I'm going to put these things on the whiteboard on the very first day. And without fail, people will get a smile on their face. And if they haven't noticed it, I'm going to point it out to them, because this is something that just creates a wow factor. You know, people take this home and they show their friends and family. So there are some patterns and relationships in the 9 times table. Other patterns and relationships between operations. I find it really helpful for problem solving. You know, what operation do we choose to do this question, to remind people that you can think of multiplication as a shortcut for adding. It's probably also true you can think of division as repeated subtracting of the same number and over again. That's a bit more of an explanation, but the one that's in front of us is pretty clear. I'm adding 1, 2, 3, 4, 5, 6. I'm adding the number 4 6 times, and then when I say it that way, I'll say, and what number just popped out there? It's 6 times. So that's 6 times the number 4, and then we transition to multiplication, which gives us the same answer. So there's a really interesting relationship between adding and multiplying, in that multiplying is a shortcut for adding the same number over and over and over again. And when I'm doing this on the whiteboard, I'll draw that little smiley face, and I'll draw the little thought bubble, and I'll hopefully put in that thought bubble what everybody in the class is thinking. Neat. Kind of, again, being explicit about my own sense of wonder and anticipating theirs. On the right side of the screen in the green, again, another relationship between operations, that repeated multiplying of the same number over and over and over again can be shortcutted by turning it into an exponent. So 5 times 5 times 5 times 5, 5 times itself 4 times is the same thing as 5 to the exponent 4. I think creating links between operations like this is a way of kind of creating a web of information that people hold in their minds, rather than, in my mind, I picture marbles loosely bouncing around without connections between them, or they're a lot harder to hold on to. So those are relationships between operations. Next slide, another slide about relationships between operations. I'll often make a joke in class that one of the beautiful things about math is that for anything you do, there will be something that you can do to undo it. So, and then I'll make the point that we wish that it was that way more often in life, that when I made a mistake, I would be able to undo it, or I did something, I could undo it. But if we start in the oval in the upper left out of the 4, I find the ovals kind of make a pretty neat visual way of helping people to see how inverse operations are related to each other. So I'll say, let's start on the left-hand side of that oval with the 6. So I'll say, we'll start with a 6, and then I'm going to follow the arrows around the circle counterclockwise. So if I take the 6 and then I subtract 2, so we're at the bottom of that oval now. If I take 6 and subtract 2, I'll arrive at an answer of 4. Then, thank you for that black arrow. Then I arrive at an answer of 4. Now, if I want to undo what I just did, I'll start with that 4. And if what I did was subtract, I'm going to do the opposite, which is add. And if I subtracted 2, then the opposite of that is adding to it. So I'm going to start with the 4, add 2, and I will arrive back at my answer of 6. So it's what we do when we double check our answers. You know, if we just did a subtraction and we have an answer, then I can add that answer back to one of the 2 numbers I subtracted and get the other. So it's the principle of inverse operations. Same thing obviously right below it for multiplying and dividing. Inverse operations, what one will do, the other will undo. But this extends way beyond add, subtract, multiply, and divide, which are the 4 basic operations we know as arithmetic. Which, by the way, arithmetic is comes from the Greek word for number art. Who knew? That's pretty neat. So, looking at the thought bubble, or the ovals on the right-hand side, this relationship of operations to having all of them having their inverse extends into trigonometry. So, if we take that oval on the top right, with the star, then let's start with 90 degrees on the left and go around counterclockwise again. So sine, I'll say to people, is an operation that works on angle numbers, on numbers that we measure angles with. So take 90 degrees, the measurement of an angle. If I take the sine of that on a calculator, the answer comes out to be 1. Now, if I take that 1 and do the inverse sine on the button on the calculator, inverse sine of 1 returns me back to 90. So what I did with sine, I was able to undo with inverse sine. I mentioned that this is stuff that we use to check our answers. It's also the kind of thing we use when we are solving algebraic equations, because when we're isolating a variable, we look to see what's being done to the variable. Well, if that's what's being done, then let me undo that by using the inverse operation. And below that, one more. So if I start with 16 on the left of the bottom right oval, start with the 16 and take the square root of the 16, I'll get 4. Well, if I've got the 4, how do I get back to where I started? Well, I'll do the inverse operation to squaring. So the square rooting, sorry, the inverse of square root is square. You know, the inverse of cube root is cubing. The inverse of 4th root is to the power of 4. So if I take the 4 and square it, I'll get back to my 16. So really neat idea that really came to me much too late in my math life, because I could have enjoyed this for even longer. But this idea that every operation has an operation that will undo it. Neat. Okay, next. Now, that relationship that we just pointed out is found on calculator keyboards. So if you look at the keyboard in front of us, there's the sine button. The button that's related to it by pushing the shift or the second function button is the inverse operation right above it. Yes, we're the stars. Next to it, same thing with cos. Cos is the one operation. Its inverse operation is right above it in yellow. On this calculator, they've organized it so that square root gets its own button. Right above the square root button is the inverse operation that will undo square root. So even the calculator keyboard, not on every calculator, but it draws out that same fact that they have grouped on this keyboard operations that are inverses of each other. Okay, second last slide. So this one's about thinking of math in the context of a person's world view. And when I say worldview, that could include a religious or a faith perspective. I believe if we can integrate our belief system and math, or anything for that matter, it's going to enrich our experience of that subject. So when I'm thinking about linking math to worldview, I don't mean turning numbers into a religion if you Google Pythagoras, you'll find out that Pythagoras did that. He founded a religious brotherhood called the Pythagoreans. And interestingly, Pythagoreans are thought of as the first society to be vegetarian, and hence the slide. Pythagoras prefers veggies. Since we don't often get into conversations with learners about worldview in our classes, this slide might be more about nurturing our own sense of wonder and curiosity about math as instructors. So back to that school where I was teaching in Malawi, I'll mention that the school where I taught in Malawi, it was a Christian school. It gave me as a Christian an opportunity to think about and articulate how math fit into my worldview. For example, I believe the permanence that's found in 1 + 1 = 2, that's a permanent fact. It says something about the permanence of the Creator. I believe the beauty found in the patterns of math is a reflection of the Creator that made it. And that when we study math, we're studying the fingerprints of the Creator. In that math class, that added an incredible richness to our studying of math because it grounded us, it grounded the subject in the belief system of the people within that room. So thinking about how math fits into the way that we understand the world and our place in it can enrich the way that we see math and our own sense of wonder and curiosity too. And the last slide, the little word yet. So I love adding yet to the end of statements when students or learners might say, I don't get this. It's great to drop the word yet at the end of that statement. It's a hopeful little word. It's a word that says, it's not that I will never get this. I think neuroplasticity has taught us that just because it was hard in the past doesn't mean it has to continue to be hard forever and ever. But adding the I don't get it and then the yet at the end keeps us hopeful that with time and effort sustained by wonder and curiosity, that soon enough it might make sense. And that's the end of my presentation. So on to summer. Thank you.
Thank you very much, Wayne. Excellent presentation for you as well. And just as I'd like to thank Barb for her incorporating humor and positivity, positive attitude, I'd like to thank you for the injection of the intention as far as curiosity and wonder in relation to math. So thank you very much. And I'd like to now turn things over to Summer.
Thank you so much, Andrea. I also have to take a minute to say how much I love the idea of incorporating humor, as Barb mentioned, maybe more than once, and wonder into math, as Wayne just discussed. When we surround mathematical concepts with excitement and fun, I think it just removes so many barriers to learning. What I'm going to share today is closely tied to that idea. It's both the theory behind and some real-life examples of adding gaming psychology to adult education. So gamification is a term you may have heard before, but for those who haven't, I'd like to kind of clarify what it means. Gamification is the act of applying game design elements and motivations to a non-game setting in order to increase engagement, change behavior, or achieve a specific desired result. One quote that I really like about gamification came from Assistant Professor Brian Arnold at the National University of California, who said that with gamification, learning isn't made into a game. The features of games which entice players to engage are used to draw in learners. That's something important to keep in mind. It's not about turning all learning activities into games, but adding game design elements or enticing features that may include an opportunity to explore, built-in competition, clear goals, an ability to measure your progress, and really importantly, a place to try and fail without lasting consequences. So what makes people want to play games anyway? When we're playing games, we often find ourselves feeling a sense of camaraderie with those we're playing with or against, a rush of excitement when we accomplish a task, a general sense of engagement, fun. So why are we feeling those things, and what keeps us coming back for more? Gamification researchers like UK Chow have examined the elements of games that give us those feelings, and Chow's work breaks it down into what he calls the 8 core drives of gaming. I'll list each of the drives that are showing here on your screen, but I'm also going to put them into gamer language as we go. The first is epic meaning and calling. It's what makes me want to participate in this game. Why is it important to me? Maybe it's the opportunity to lead a rebellion to success or come together to beat a pandemic. Next is development and accomplishment. How do I know I'm progressing while I play? Do I get to level up, earn badges, see points, get rewards? Being only a few hundred points from leveling up in your game is to blame for a lot of very late nights. Then we have empowerment and creativity. Can I do things over again in a new way to see if it improves my game? The ability to pause, reset a level, and start again at full health so I can avoid a pitfall that almost got me last time. Actually, that's something we probably wish we could do in real life a lot of the time. Next is ownership and possession. This game, this journey is mine, and I care if it's successful. I will not let that invading army take my castle. Then we have social influence and relatedness. It's a feeling of community with those I'm playing with, and a great opportunity for me to measure my skills against theirs too. Bring on a leaderboard or the ability to be in charge of a team. We also have scarcity and impatience. If something in the game is limited, either in number available or a time period when you can get it, well, I'll work harder and longer for it as a result. Items like rare gems or knowing you're one of only a limited number of bonus prizes can be very motivating. Then there's unpredictability and curiosity. That's the whoa, I didn't expect that moment. The card I pulled just took the game in a whole new direction, and now I want to stick around and see what happens next. And finally, there's loss and avoidance. If I don't keep playing or check in on my game every day, I'm going to miss out on something. My Farmville crops or cow will die, and I cannot have that on my conscience. Understanding the core drives of gaming give us some great tools to motivate people to play, but gamification is not a one-size-fits-all solution. To design a meaningful gamified experience, you need to understand your individual audience and what drives them specifically. This is a bit like what Barb referred to earlier about seeking input from learners when you're planning your lessons. One method of learning about your audience, from a gamification perspective at least, is through testing their gamer psychology. There are several online multiple choice assessments that analyze the user's instincts and choices against 4 gamer types with different learning styles. Many gamification experts and practitioners use the Bartle test of gamer psychology, but it's just one of several available online. Knowing which gamer type your audience most closely associates with can help you design gamified math activities that resonate with the learners you're trying to reach. We'll use the Bartle test for our primary example. It weighs the learner's answers into categories of explorer, achiever, socializer, and killer. Learners who score high in the explorer category are gamers that like the freedom to wander and discover things about elements of the game through experimentation. They like to figure out how things work and are probably the person you want on your Friday night trivia team. Those who score high in the achievers category will be pretty happy to hear that, because they're point-oriented gamers who enjoy being at the top of the leaderboard or who want to be rewarded for being the first one to finish something. Goal-oriented, these learners may not see the value in math games unless there is a clearly defined winner, and it can be them. Learners with a high socializer score are motivated by meaningful interactions and relationships, and often view gaming as a way to make or connect with friends. They are the networkers in our midst, and seek out other like-minded gamers to work together to achieve more than they could alone. Collaborators. And they probably want to stay the heck away from those who score high in the killer category. While achievers take pleasure in the act of winning, killers tend to enjoy the act of defeating an opponent more than the act of winning itself. Because winning is often secondary to the game, killers are not as discouraged by failure and tend to be more risk takers as a result. Other quizzes use the same input patterns but change the names of the categories, so you might end up with innovators, strategists, effectors, and aces in the end. But the philosophy is the same. And understanding how and why gamer psychology impacts your learners is a great tool to help you craft effective math exercises in your classroom. That said, helping adult learners upgrade their math skills so they can be successful is pretty serious business. So why would we even want to encourage gaming mindset in adult literacy programs anyway? Just look at the commitment being shown by the average gamer who is only one level away from an epic win in the game of their choice. The passion, dedication, drive, who wouldn't want that from their learners? Gaming traits include problem solving, collaboration skills, focus, and continual skill development. And perhaps most importantly, gamers fail all the time. Okay, so maybe a game piece gets thrown across the room or a controller gets slammed down on the table out of frustration. But you know what happens next? The gamer thinks, all right, I know that didn't work. And they pick the controller back up and they try again, learning from what went wrong last time so they can achieve a different and hopefully better outcome this time. And frankly, people don't get excited about mastering an element of a game that's really easy. Overcoming the challenge is what gives gamers a sense of pride and accomplishment in their skills. Harnessed in an educational setting, these are really powerful traits for success. In the unique environment of an adult literacy classroom, I'd argue that there are even greater benefits. Consider using gaming elements as a motivational tool to allow learners to gain confidence just by doing something better than they did last time, even if they aren't successful. Replace the measuring stick, and clients can recognize and celebrate success by learning from their mistakes and making small improvements, rather than by comparing their skills to other people who may have very different skills, abilities, and barriers than they do. As the use of gamification grows in fields like marketing, healthcare, and education, we have to look at ways it doesn't work as well as ways it does. With its growing popularity as a tool, a lot of people are adding concepts of gamification into their initiatives. That doesn't mean it's being done well, though. As I said earlier, adding game elements to something that your target audience doesn't connect with isn't going to suddenly make it work. Successful gamification strategies have to go beyond just adding points, levels, or rewards. Otherwise, a blank screen that invites the user to repetitively click a single button to earn points would be the most exciting and popular game in the world. Some of the most common mistakes people make when trying to incorporate gamification into a learning environment include misinterpreting what actually motivates their audience. As an example, just because competition drives some gamers does not mean it drives everyone. In fact, adding a ranking chart to compare the math scores of a room full of people who feel self-conscious about their skills and abilities can motivate them right out the door. Adding badges, levels, or point values on absolutely everything is a mistake as well. Don't get me wrong, those tools can be very motivating, but rewarding users for easily obtained tasks actually make the points seem arbitrary or even condescending. Adult learners are unlikely to invest time and energy in learning mathematical concepts if they feel like they're being pandered to. And finally, adding out-of-context gaming elements. At the beginning of my portion of the presentation, I mentioned that gamification is about the process of engaging people in learning using the same things that engage them in games, not necessarily turning learning itself into a game. While there are lots of great examples of learning games, simply making a learning activity into a game isn't actually gamification. And out of context, it can be really confusing. So, if we're talking about what goes wrong when gamification is done poorly, there must be a flip side. We have a host of examples of gamification in marketing, healthcare, children's education, and the adult education field. Since we work with adult learners attempting to grow their math skills and become successful, I'll focus on sharing examples of gamification in action in an adult literacy environment. The two I'm sharing today have deeply embedded math content that I think you'll find interesting. First, the Thames Valley District School Board's Gateway program developed a cutting-edge training opportunity for their students to learn traditional literacy concepts in a very non-traditional way. The course is called Arducopter and includes elements of math, technology, geography, and hands-on learning, all used as participants build a remote-controlled drone helicopter from scratch and send it on an actual flight. The course takes learners who are highly motivated by the concept of both hands-on building and the cool factor of flying a drone through exercises about their own learning style, workshop safety, technical terminology, and diverse mathematical concepts. Lessons bounce back and forth between research-based to hands-on building to exercise-based, keeping learners active and engaged in each component of the course in small chunks. And best of all, they see their progress being built bit by bit as they assemble their class quadcopter together. What I think is particularly cool about this course is the embedded mathematical concepts. If you were to say to most adult learners, hey, do you want to spend a couple of hours learning about calculating area and perimeter? I suspect you may get a lukewarm response. Ask some of those same learners, hey, do you want to spend a couple of hours learning how to fly a drone helicopter? We'll need to know how to complete area and perimeter calculations to program the flight software. Are you in? I think you might get a slightly different response. The second example I wanted to share is a program that was piloted in London and has gathered some national attention, having won an honorable mention in ABC Life Literacy's Canada-wide 2016 Innovation Awards. Targeting male youth aged 19 to 29 who were not in education, employment, or training, our Innovate project is a place-based learning initiative bringing literacy programming to basketball courts using a trio of really cool tools. At the heart of the program is the 9450 Smart Sensor Basketball. It's a basketball that looks and feels just like any other, but that has sensors embedded within it that measure any force applied to it. Spin, acceleration, dribble speed, anything. Used with the 9450 app and the Smart Net, players and facilitators get a full 360-degree view of what's happening with the ball and the player who moves it. The module that was designed to accompany this trio of tools takes learners not through just basketball drills to improve their skills, but gives them an opportunity to learn and apply mathematical concepts as they calculate angles and speeds and track their individual and squad stats. As their skills and knowledge increase, learners progress through levels including rookie, starter, all-star, MVP, and more. Not only does this project use some pretty fascinating technology, but it demonstrates a neat take on one of the keys of successful gamification. Rather than taking existing curriculum and adding gaming elements that we hope would appeal to the intended audience, the team looked at what was already a driving force in these young men's lives, and then created the curriculum around it. They were avid basketball players who, while not committed to working or attending school, were committed to practicing their basketball skills. So why not meet them where they're at? So those are just two examples of what's already happening with gamification and adult literacy, and it begs the question, what else could we be doing? One idea I'm very excited about is the idea of working with smart soccer balls, because there is such a universal appeal to the beautiful game. And the idea of creating activities for learners that compare the stats of their favorite teams and players is just ripe for possibilities. I know a few people who'd like to dig into Manchester United versus Liverpool from a stats perspective. I think it could be a good motivator. Escape rooms, for those who've done them, offer a lot of opportunity for problem solving, mathematical or otherwise. And the world of augmented reality just continues to grow in leaps and bounds. It's within the realm of possibility that we could have a virtual version of René Descartes himself explaining the Cartesian plane to adult learners in your classroom. I invite you to consider those possibilities, and please feel free to add them to the text chat so we can share them with others. With that, I'm going to hand our presentation back to Andrea for, I believe, our Q&A.
Thank you very much, Summer, for an excellent presentation. Really appreciate your sharing creative and playful approaches to making math fun. I just wanted to mention that there are resources that have been shared with us about using videos and blogs and cartoons. These were put together by Sue Gold, Learning Facilitator, Adult Learning Center in Owen Sound, and she told us that Steve Ballard did a fantastic job putting the videos as well as the blog called Rugs, or really useful GED stuff, together. So in the interest of time, so we have time for question and answer. I will just make quick mention of these, and then we'll head to the question and answer period. So one of the videos is about multiplication. We have a number of videos about fractions, and these will be in the presentation PowerPoint you received, so you can spend more time looking at them later. Videos on percents. This is the information about the blog. And then we've got a couple of websites as well. And there are additional resources for gamification. So we encourage you to research these further. And thank you to the presenters and contributors to this webinar. However, the presenters are not quite finished for today because we're going to move into the question and answer segment of today's webinar. So if you have some questions, you can either type them in the text chat, or you can raise your hand.
Andrea, while folks are thinking, I'll ask you to give me a heads up when you want me to go to our evaluation screen, because we know a lot of people have expressed appreciation to our wonderful presenters today, and we don't want to miss getting evidence of that.
Thank you for bringing that to my attention, Sarah, and you can put that up anytime. And we'll just keep monitoring here for questions. It looks like there's a lot of positive feedback and some questions from to find out more from other folks. Jim asked, how has anyone used gamification? So if people would like to put in text chat anything that they've been doing, that would be great. Oh, and we have a question here from Paula. Wayne, what are your go-to resources for math? Would you like to help us with that one, Wayne?
I guess I've got some resources that we use as kind of our go-to. Number Sense became Math Sense. We've been using Math Sense. One thing that I'm deliberately trying to do, though, is encourage people to find their own resources. So they might be working out of a resource like Math Sense, and I'm connecting them with the Khan Academy, or encouraging them to go to YouTube and find other presenters, because I think there's real value in people realizing that I'm not the only source of content, that even when the teacher's not there or the other people in the learning team aren't there, that someone can look up stuff on YouTube or anywhere else on the web and continue to learn themselves. So I do have that go-to. Is probably Math Sense is the one that we use, but Khan Academy is the first place I'll send people if they say to me that the explanation here just isn't speaking my language. I'll send them off there.
Thank you very much, Wayne. There's a question here from Jacqueline. What website is recommended to go to in order to evaluate a learner's gaming style? I'm thinking that's directed towards Summer.
So I'll give a shout out to TM, who managed to find a URL for us just after I had said I don't have the URL in my head. TM was able to find one, and it's been listed in the comments. So it looks like mathewbarr.co.uk/Bartle/. So if everybody wants to take a look down there, it's hiding waiting for you.
That's wonderful, Summer. I see that the answer was already in text chat. Oh, and Sarah's reminding everyone, please remember there's an incentive draw for those who complete the evaluation. Thank you, Sarah. Are there any other questions that people have, either in text chat or if you want to raise your hand?
And this isn't the end, folks. Remember that there are 2 more webinars in this series, and I don't know if you were going to mention anything about those today, Andrea?
I was just trying to click onto that item, but with the evaluation there, that slide isn't coming up. So the thank you slide.
Yes, I won't interrupt people while they're doing their evaluations, but I will mention that you will get the information about our upcoming webinars and the links for registration if you're interested. Our next one will not be until January because we think many of you will have other things on your agendas for December, but we look forward to having you participate with us again soon.
Thank you very much, Sarah. We'd really appreciate it if you could take the 3 to 5 minutes of your time to complete the evaluation. Your feedback is very important to us. So important, in fact, that we're having a draw. If you complete the evaluation and provide your name and an email address, you'll be entered into a draw for a $25 gift card. And as Sarah mentioned, there is another webinar coming up, Math Resources. That's January 24th from 2 to 3:30, and so we encourage you to register for that. Okay, and a question there for TM about the PowerPoint. I'll let you respond to that one, Sarah.
It would help if I unmuted. Sorry about that, TM. The PowerPoint is going to come to you first directly in email, and I will have the links in the email. It is on the e-channel.ca site. On the practitioners page, we have an online community of practice resources page there, but I will be sending you the link to that resources page in the follow-up messaging. If it doesn't reach you tonight because of the software that sends it out, it will be coming to you in upcoming hours, before the morning, I hope.
And for those who have taken all 5 or who do take all 5 webinars, you can request a certificate of recognition. That's new this year, so good for your professional development portfolio. So thanks to our presenters and thanks to you today, our audience. I hope that you've enjoyed the presentations. All 3 presenters did a fantastic job, so thank you again to our presenters.
And thank you, TM, for posting that link yourself. I'm sorry when I'm watching here. I'm a little leery lest I kick myself out by getting into too many tabs. Thanks so much.
Well, it looks like we've come to the end of the session for today. So thank you very much, everyone, for your participation. And we hope this will help you in your work in promoting the positive, wonderful world of math.
And I add my thanks to all of our presenters and to Andrea, who's worked with them to put together a fabulous presentation that's rounded out all sorts of different ways to make math not only fun but a really positive experience and one that can induce wonder in us all. So I will encourage people who are still working on their evaluation to take your time. I will be the last one to leave this afternoon, so there's no rush. Others may leave when they are comfortable, and if there are any late questions in the text chat, I'll make sure that I pass them on to our presenters. So have a great evening. Stay safe as the winter draws upon us, and I hope it's a wonderful upcoming season for everyone.